Have you ever wondered how a paleontologist can pick up a piece of skull or a piece of hip bone and then tell you whether it's of a human ancestor or not? I can explain. Actually, you've probably already made this determination yourself. Looking at this model beside me of this skeleton, you probably have determined clearly that it's of a human skeleton. And that determination, of course, is because of its upright posture and the fact that it's standing on two legs. It means that it's bipedal. Bi meaning two, pedal meaning feet. So this is a bipedal human being. Now, bipedalism is nothing unique to human beings. Kangaroos have a type of bipedalism. Birds, they walk on two legs, and even their relatives, the theropod dinosaurs, walk on two legs. Here's a Caudipteryx model, and then this is a model of a Microraptor, okay, relatives to the birds that you hear in the background. Okay. And you can see actually from this Caudipteryx is that its backbone, okay, has a little curve to it, okay, as does this Microraptor. Okay, let's move ahead 100 million years approximately from these relatives of birds to a mammal. In fact, this mammal is a little black bear. Okay? This little black bear also has a curved backbone, a convex backbone, making an arch. And you can see the reason is that an arch is a very stable structure, and since this bear is walking on four legs, okay, that makes his body very stable. So this is a quadruped, meaning four for quadra, ped meaning feet, so it's quadruped. So with this curved backbone inference of the theropod dinosaurs, that means that in fact these guys were walking like a quadruped. So yes, despite it not being obvious, birds are actually quadrupeds, and you can see this actually when they're flying. They fly horizontal to the ground. But let's get back to apes, to us. Okay? In the first diagram, we will compare the backbones of the apes. As you look across the diagram, you can see there's a more convex curve to the backbones of all the apes except for man. The human backbone is S-shaped. You can see that in the blue arrow. You can compare it to the gorilla backbone, which is in the red arrow. Even though the other apes in this figure are standing on their hind legs, they are bent forward, being considered quadrupeds walking on all four legs, which is consistent with the convex arch shape of their backbone. The S shape of the human spine puts the body center of gravity within the pelvic girdle. So a human has to stand up straight, vertical to the ground, to balance properly. So the distinguishing feature of a human is upright bipedal posture. Any primate fossil found with an upright bipedal feature is thus placed in the line of human ancestors. So you never find a complete fossilized skeleton, or very rarely. So you actually have to work with the major landmark features that have been generated by bipedalism, and those are generally on the large bones. Those biggest bones, of course, are the skull and the hip bones. So specifically, we want to look at the skull relative to the hole in which the spinal cord enters. Okay, we'll rotate it here, and you see this is where the spinal cord enters into the skull, and this hole is called the foramen magnum. Foramen is a hole in the bone, okay, and magnum means big, so this is the big hole where the spinal cord enters into the skull, okay, of humans. Okay. So we'll rotate it, it's right here, so we'll rotate it this direction. So again, we're looking at line of sight, which is this way, and then the position of the foramen magnum in the humans is 90 degrees. Now let's imagine this is a gorilla's skull, okay, and we will look at the position of the foramen magnum on the gorilla's skull, and because the gorilla is a quadruped, you know, their spine comes in further back on the skull, right about here, and when you measure that angle, That's about 140 degrees.
This next diagram shows the foramen magnum position of the gorilla, a chimpanzee, and a human skull, and the relative position of the entrance of the spine. This diagram comes from a very nice blog by James R. McClanahan called How to Tell If a Fossil Hominid Was Bipedal. The URL for this blog is in the notes.
Okay, the other major feature of bipedalism in the skeleton was the hip bone. And this region here is actually called the pelvic girdle. And that pelvic girdle is made up of the sacrum, which is 5 fused vertebrae, and then that allows the attachment of the hip bones. The hip bone itself is made of 3 fused bones: the ilium, this upper area, this crest area here; the ischium, which is right here, is actually the bone you sit on; and then the pubis, which is the front part. Now this pelvic bowl here is used to keep us upright, and the gluteal muscles come in here, and because of this short distance, it makes them bunch up. Okay? So that gives us this big butt, the big human butt, and it keeps us from falling side to side and tipping over.
This third diagram also comes from James R. McClanahan's blog and shows a comparison of the human and ape pelvic girdle. The ape pelvic girdle is flattened and thinner, see the red arrow, and the blades of the ilium are straight. Now compare this with the human pelvic girdle, which forms an obvious bowl shape with the blades of the ilium curved forward, indicated by the blue line. Thus, if the fossil ilium you are examining has this curved forward shape, it indicates there's an upright bipedal posture.
Obviously, there are other features related to bipedalism on the skeleton, but as you can see, simply by looking at the skull and the hip bones, we can actually make a determination on whether this is a human ancestor. And this is a good thing because these are the big bones, and the bigger the bone, the more chance it has of being preserved. Now, remember, to determine whether you're in the subfamily Hominimina, which means you have an upright bipedal posture, you have to look at the skull and the hip bones. And remember, with the skull, it's the position of the foramen magnum, the big hole here, related to the line of sight. Okay? Line of sight here, spinal column entering here, that has to be 90 degrees. And when we look at the hips, we want to look at the ilial bone, and that ilial bone has to be curved forward. And if it's curved forward, that means that you have these nice gluteal muscles here, and you're standing upright, okay, in a bipedal posture.